Hey pre-calc students, this is Ms. Carranza, and today we're going to talk about domain and range written in interval notation. So this is lesson 1.2 notes, part 1. As you remember, a couple days ago we discussed that functions are a set of ordered pairs that pass the vertical line test. So don't forget that you do need to know how to do that now to identify whether something is a function or not. So let me just remind you what we discussed in class. Again, don't forget a function has to pass the vertical line test. We talked about how the first two examples here are functions because no matter how many vertical lines you draw through the relation, it's never going to have two ordered pairs on the same vertical line. Whereas this example and this one do not pass the vertical line test because if you were to draw a vertical line through this sideways parabola, it would hit more than once, right? It would hit two ordered pairs at the same time. Over here, this last one, A and C, the ordered pairs A and C are within that vertical line. That is not allowed. Okay, so that's just a quick review of what is a function. So we're going to keep focusing on functions, but specifically today, we're going to talk about the domain and the range. So if you remember back to other classes you've taken, domain refers to the set of x values. Okay, so it's really important for you guys to know that domain is x, whereas range talks about the y values. And these are the y values and x values that are defined for that function, meaning it includes the x and the y values of any ordered pair on the function. Please make sure that as you're writing these, you always write them in increasing order. So write yourself a little note to write answers in increasing order. So from lowest to highest, you're going to hear me say that a lot, from lowest to highest. Okay, in other classes, you may have used set notation, but this year we're going to focus on interval notation, and that requires you to use brackets for included values and parentheses for excluded values. Now let's think about brackets first. Brackets means that your function stops or hits an exact point. Parentheses are when your function approaches a certain value. So infinity, a function will approach infinity or, go infinitely to the left or to the right, but will never reach the end because there's no end in infinity. The parentheses you're also going to use for any excluded values, any open points, whereas brackets are used for closed points. So take a second, go ahead and write down what you need to. Brackets are for included values. That includes finite, meaning that they end, or closed points. Whereas parentheses, okay, are excluded values, so your function will get close to them. Same with like asymptotes. It includes infinite values or open points. It'll make a little more sense once we look at specific examples. Okay, determine the domain and range of each function. All right, if you look at number 1, that is an absolute value function. To find the domain first, we're going to go ahead and remind ourselves that x is asking you for the domain values. X is the domain. So if you look at the x-axis, the positives are on the right, the negatives are on the left. Look at the arrows, okay? Look at the arrows. Where are they pointing? You're going to look at it from left to right. So these arrows are pointing forever to the left. There's no stopping it. This function is going to go forever and ever and ever to the left. So there is no lowest x value because this goes forever to the left. So you would say that it goes forever to infinity. Remember, parentheses are used for infinite or open points, okay? Infinite or open points. So infinities or values that it approaches but will never reach. Okay, remember we're looking at the graph on the left side and the right side. So now we're looking at what's happening with this function as it goes to the right. this goes forever, forever, forever to the right. So this domain is going to be positive infinity, or sorry, from negative infinity to positive infinity. The left side goes forever to the left, and the right side goes forever to the right. Domain asks you, how far does it go to the left? How far does it go to the right? Feel free to write yourself a little note, right? X is asking you how far left and how far right. Range, however, is asking you for the Y value. So that one's asking you how low and how high it goes. Remember, you want to write your values in increasing order, so you want to start from the lowest first. Sorry, I just knocked over my computer a little. Okay, so lowest to the highest. There is no arrow pointing down forever. So this absolute value does have a low point, and that's the vertex. Okay, so that ordered pair is 2, 1. But remember, we're asking about the range, and that focuses on the Y value. So we don't really care what the X value is. We are caring about the Y value. The lowest Y value is 1. Now the absolute value has an exact point at 1. So whenever your function has an exact value or a closed point, you're going to use a bracket for that value. So the lowest is 1. Now remember, we're focusing on the y-axis. So here are the positive y values, negative y values. How high does this absolute value go? Well, focus on the arrows again. Think of it as going forever up, right? So there's no stop in this thing. This absolute value function is going to get higher and higher and higher and higher. So it approaches infinity. Remember, infinities get parentheses, not brackets. Bracket was only used in the range in this case because that was the lowest that it went. It didn't go any further, and it hit exactly a value of 1 on the y-axis. Okay. Domain is how far left and right it goes. So remember, you want to tell me what's happening on the left side. So let's take a look at the arrow over here. Yes, this arrow is pointing down, but we're not thinking about whether this points up or down. Right now, we're thinking about what's happening to it from left to right. So is it getting wider or not? A parabola is going to get wider and wider and wider the farther out you go on the left. So you can imagine it's going to get wider and wider and wider. So it keeps getting wider and wider. So it's approaching negative infinity, because remember, the negative x values are on the left. So no matter what, this thing is going to go forever to the left because it gets wider and wider. Same thing on the right. So again, yes, these arrows point down, but when you're talking about domain, you're focusing on how far left and how far right this thing is going to go. So this quadratic function will keep getting wider and wider. There's no stopping how wide it's going to be. So it's negative infinity is the lowest to positive infinity. Now you can start thinking about up and down. How low does it go and how high does it go? So you're reading, always look for arrows, right? So these arrows are pointing down. And actually, let's look at the original arrows. These arrows are pointing down. There's no stopping how low this thing is going to go. So remember, negative y values are on the bottom, positive y values are on the top. So this thing is just going to keep going. This quadratic is going to keep going down and down and further down and further down. But there are no arrows pointing up forever, right? The vertex is the highest point. So that ordered pair is negative 3, 1. But again, when it comes to range, we don't care about the x values. Range is the y values. So the highest that it goes on the y-axis is 1. And it has an ordered pair exactly at 1. So when it lands exactly on an ordered pair, you're going to use a bracket. Okay, how are you guys doing so far? Remember, you can always ask me for help by sending me a message on Remind, or you can come in for help during ATR. Okay, continuing on to the next one. Remember, domain is how far left and right a function reaches on the x-axis. So here are the negative x's, positive x's. So this is a cubic, okay? Now cubics also get wider and wider and wider the more you go to the left and the more you go to the right. So cubics, like quadratics, and absolute value, in case you haven't noticed the domain so far, there's been a pattern. Always go forever to the left and forever to the right. That is always true for the domain of absolute value, quadratics, and cubics. It's characteristic of their shapes. Okay, range, however, remember those are the y values. You have to look at what the lowest point and the highest point is. Well, guess what? There's an arrow pointing down. So there is no lowest point on the y-axis. It's going to go forever down on the y-axis. There's no stopping it. It's going to keep going lower and lower. Look at the arrow up at the top. Same thing. It's going to go forever to positive infinity. You don't have to put the little plus sign, by the way. My suggestion is always look at the arrows. If it's pointing forever up or forever down, you're going to use infinities. Probably the trickiest one of all is the rational because of the asymptotes. So I'm going to go ahead and highlight these asymptotes because I want you guys to remember what the definition of an asymptote is. An asymptote is an imaginary line that your function gets really, really close to but will never, ever touch or intersect. So no matter what, these two wings or these two curves of the rational function will get really close to the values of the asymptotes but will never, ever intersect them. So because it will never intersect them, you're not going to use brackets, okay? Brackets are only if your function touches at that exact value, okay? So these are approaching, so they're going to get close to it, but not exactly. Okay, so let's focus on domain for a second. Domain is how far left and right it goes, okay? Is there an arrow pointing to the left? Yes. Are there some arrows pointing forever to the right? Looks like it, right? This arrow over here looks like it's pointing forever to the right. And this arrow looks like it's pointing forever to the left. But they are from different curves. They're from the different pieces of the rational function. So whenever there is an asymptote that kind of cuts it, like here, there's two arches, you can't say that the domain is from negative infinity to positive infinity because there's this area right here in the domain on the x-axis where there are no ordered pairs. Okay, the left arch, right? The left curve and the right curve don't have any ordered pairs on that little section that I just circled. So I'm going to read this part, right? From left to right, this curve will never intersect this piece. This curve over here picks up where the other one left off in a way and goes forever to the right. Because of this break, because of this little space right here where there are no ordered pairs, we need to be careful and not say that the domain is negative infinity to positive infinity. We're going to look at one curve at a time. So let's look at the left curve, okay? I'm just going to label it, the left curve. That one does go forever to the left, but it stops at this value on the x-axis, which is 4. Now, does it stop exactly at 4? Will the function intersect the value of 4? Will have any ordered pairs with a 4 as an x value? No. It approaches it, so you're going to use parentheses. Remember, brackets are only if your function hits that exact value. Now, the right curve picks up where the other one left off, right? So it gets really close to 4. So we're looking at the left half of this arc. It picks up at 4, and then that one goes forever to the right. Because there are two pieces of this function, we use a little union symbol. It looks like a little U to say that there are two pieces, but all part of the same function. So again, look at the asymptotes to help you, okay? Okay, range has to do with the y values. So now we're going to look at the y-axis, and that's the other asymptote. That's this one here. Okay. So we want to look at this from lowest to highest. So which curve is lowest? It's the left curve, okay? Now this curve has an arrow pointing down forever. So the domain of the left curve is negative infinity. I started with the left curve because that's the lowest. Remember, you always want to go from lowest to highest. Okay, so the range goes forever down, but it doesn't go forever up. Remember, this is kind of like the ceiling, this horizontal line. So your curve can't go past it. It's stuck under it. So you want to say that it's from negative infinity to, that's a value of 2. Now it gets really close to it, okay, but we'll never intersect it. The second curve, which is the curve over here, the right curve, now that one picks up where the other one left off. Remember, we're looking from lowest to highest, so it actually starts around 4 and then shoots up to infinity. Or sorry, what value is that? 2. Value of 2. Remember, we're looking at the y-axis, 2 to infinity. So remember, when you are dealing with rational functions, use the asymptotes. Use the value of the asymptotes to help you write the domain and the range. The domain and the range are not negative infinity to positive infinity because the asymptotes create a break, okay? Like a separation between the curves. So it's not one continuous curve. Okay, square root. Domain is how far left and right this function goes. There is an arrow forever to the left, but there is no arrow forever to the right. So the farthest that it goes is this initial point, which is negative 2 comma 3. But remember, we're focusing right now on the x values because we're in domain. So the farthest to the right that it goes is negative 2. Because it stops exactly at that point, we're going to go ahead, or at that value, we're going to put a bracket because that's for finite exact included points. The range is how low and how high it goes. So remember, we're thinking now lowest to highest, and we're looking at it from bottom up. So on the bottom, this square root is going to get lower and lower and lower and lower and lower. So it's going to keep going lower and lower to negative infinity, slowly but surely. It does not go forever up, though. The highest that it goes is this initial point. Because we're dealing with range, we want to see what that highest y value is, and that y value is 3. Remember, you guys can always pause, rewind the video, and you could always ask questions if you have any. Okay, we've got another square root. Remember, domain asks you to look at it from left to right. So it doesn't go forever to the left. The initial point is the farthest left point on this square root function. So that ordered pair is 0, negative 2. But we're dealing with domain, and domain has asked for the x value. So the farthest to the left is 0. Why did I use a bracket? Okay, hopefully you said because it lands exactly, because there's a point exactly on that value of 0, okay? Okay, now we're going from left to right, so lowest to highest. That's the farthest left that it goes. Now we're going to look at the farthest right. This has an arrow pointing forever to the right. Remember that infinities get parentheses. Also, any value of an asymptote, right? When your function approaches a value from an asymptote, that's also going to be parentheses. This definitely takes practice, guys, so be patient with yourselves. Again, you can always watch the video again, pause, rewind. Okay, range asks you how low and how high it goes. So the lowest point on this graph, so now I'm looking at it from lowest to highest, okay? The lowest point is this initial point. Now we're interested in the y value. Because there's a point exactly at 0, negative 2, I'm going to use brackets. Now I got to ask myself, how high does it go? So yes, this arrow is pointing to the right, but it also is pointing up, right? It's up and to the right. So since it's pointing up and it's going to go forever up, higher and higher and higher, you're going to say that the range is from -2 to infinity. Okay, so I'd like you to pause the video and graph number 7 and 8 by yourselves with a table of values. And then you can go ahead and push play when you've graphed both of them, and we'll talk about their domain and range. Okay, so for number 7, this function was shifted left 1. Okay, so it wasn't shifted up or down. So I'm going to draw my new origin at -1, 0. The table of values I'm using is the one from -2 to +2. However, because there's a negative out in front, that's a reflection over the x-axis, which means that the y values change signs. So I'm going to go ahead and change the y values. Oops. Haha, 0 doesn't have a -0. So from this new origin, -1, 0, I'm going to go ahead and plot -2, -2, -1, -1. Oops, I didn't go far enough. Beep. Okay, so from here, I'm going to go left 2, down 2, left 1, down 1, right? So -1, -1. Then this is my new origin, 0, 0. From there, I'm going to go right 1, down 1, 1, -1, and 2, -2. I don't know if you remember me saying this, but absolute values always get wider and wider and wider. So the domain is going to be -infinity to +infinity, because remember, it's asking you how far left and how far right it reaches. There's no stopping how wide this absolute value is going to get. So it's going to go forever to the left where the negatives are and forever to the right where the positive x values are. Now the range, you have to look at the arrows, right? You always want to look at it from the bottom up, lowest to highest. There are arrows pointing down forever, so this thing is definitely going forever. Oops, that's supposed to say lowest. Okay, so from -infinity to, let's see, does it go forever up? Nope. The highest value is this one, which is -1, 0. But remember, we're talking about the range, so I want to know what the y value is. Range is always y, domain is x. And kids, as you can tell, sometimes my infinity symbols look a little crazy, so don't feel bad if your infinity symbols look funny. Okay, so the highest y value is 0. You always want to go from lowest to highest. Okay, I really truly hope that you remember that if the x is negative inside the grouping symbol, you have to factor out the -1. And remember, check yourself. So if you distribute this back in, -1 times x is -x, just like the original, and -1 times -1 is +1, just like the original. Okay, so what this means is that we've got to shift right 1. And this is a square root function, so I'm going to go ahead and use the table of values that's appropriate for square roots. That is not -2 to +2. For square roots, we use 0, 1, and 4, because those are numbers that are easily square rooted. Square root of 0 is 0, square root of 1, 1, square root of 4 is 2. Because there is a negative inside, that means that I've got a reflection over the y-axis. When something's reflected over the y-axis, the x values change signs. So I'm going to go ahead and change those from my table. My new origin, since I'm shifting from 0, 0, and I'm moving right 1, it's going to be here now, my new origin. Okay, now I'm going to plot the points 0, 0 from that new origin, left 1, up 1, and left 4 from the new origin, 1, 2, 3, 4, up 2. Okay, domain is asking you how far left and how far right this function reaches. So as I look at the left, the arrow is pointing forever to the left. So that's going to be negative infinity. Remember, infinities require you to use parentheses. But there is no arrow pointing forever to the right. The farthest right that this thing reaches is this ordered pair of 1, 0. But right now we're talking about domain, so I only care about that x value. So I'm going to put down 1. Should I use brackets or parentheses on this one? Well, because there's an exact ordered pair of the function, the square root function, on the ordered pair 1, 0, and it's exactly on there and it's included and part of the function, I'm going to put brackets. Remember, brackets are around included, closed points that are exactly on the function, exactly at that value. Okay, now let's think about range. Range asks you to see what the lowest and the highest values are. Well, the lowest value of the square root function is that initial point of 1, 0. So this is the lowest point. Now we're talking about the y values. So the lowest y value is 0. Again, I'm using brackets because there's an exact point at 1, 0. So that's the lowest point. What's the highest point? Well, there is no high. This thing is going to slowly but surely get higher and higher and higher and higher. So again, slowly but surely, it's going to approach positive infinity. It's going to go up and up and up. Okay, last one. We're kind of going backwards here. So they're already describing the domain and range of something, and you have to draw it. So first of all, we've got a quadratic function. So that's the first piece of information they gave us. Quadratic functions are parabolas. We don't know if this one opens up or down, but feel free to make a little sketch so that you know what shape you're going to draw. The domain is negative infinity to positive infinity. Well, that's kind of like a duh. Parabolas always get wider. So it goes forever to the left and forever to the right. But they're saying the range, remember the range is how low and how high. They're saying that this thing goes down forever, but the highest it goes is 4. Well, which parabola goes down forever? Not the one that opens up, the one that opens down. So we need a parabola that opens down where the highest y value, remember range is y value, the highest y value is 4. So here's the y-axis, here's 4. And as long as you draw a parabola that opens down and is lower than that and has, right, a vertex that hits 4, it would count. So that would be an acceptable answer. This one would be an acceptable answer. Do you guys see how there are multiple possibilities here? Okay. Think about it. Domain and range is not a new concept. It's something you guys have studied before, but of course, we tend to forget things. So hopefully this was a good refresher, but if you still want extra practice or help, message me and I'll be glad to help. Have a good day, guys.